All right, so in this lesson, we're going to be describing angle pairs and their relationships. The vocabulary that you're going to encounter in this lesson, you will see more than likely on a lot of standardized tests. You'll see it on the PSAT, your SAT, your ACT. So this angle relationships of complementary, supplementary, vertical, you may encounter questions on standardized tests. So it's a good idea to understand and memorize all of this vocabulary. So the first angle relationships we're going to talk about today are complementary, supplementary, and adjacent. So when you have two angles whose measures have the sum of 90 degrees, we say that those angles are complementary. When we have two angles whose sum is 180 degrees, we say those are supplementary angles. Now, try to maybe come up with a little trick or some kind of way to memorize or help you remember which ones equal 90 and which angles equal 180. One little trick that sometimes I would do is remember that the letter C comes before the letter S in the alphabet. So 90 is less than 180 and it would come first. Another little thing that you could do is take the word complementary. So if I were to take the CO from complementary, I'll just begin to write the word. I could turn that into a 90. Put a little stick there with the C, and it sort of looks like a 90 here from the CO. Whatever's going to help you remember. If you take the word supplementary, you could take that S, and you could turn it into an 8 by adding a line. And then maybe that would help you remember that that's the one that's 180. But just memorize that complementary angles, they sum to 90 and supplementary to 180. The next type of angle pair we're going to talk about is adjacent. Can anyone, not talking math here, tell me the definition of the word adjacent? Next to each other. Okay, so when we're talking about adjacent angles, we're talking about two angles that are next to each other. They're going to share a common vertex and a side, but they're not going to have common interior points. So they'll be next to each other. Now, in the examples or the figures there, we have a picture of complementary angles. Notice the little square here in the bottom indicating a 90-degree angle. So when you have two angles that their sum is 90 degrees, they're complementary. Okay? We can have angles that are complementary and we can also label them as adjacent because they're side by side. But notice with angles 3 and 4, these are non-adjacent. But if I put in some numbers here and I said angle 3 was 30 and angle 4 is 60, I could say that they're complementary, but they're not adjacent. Same thing with the supplementary angles. You can have supplementary angles that are adjacent and then non-adjacent, they do not touch. So in this one, if this was 120, we could say 6 is 60 because 120 plus 60 gives me 180 degrees. Any questions on complementary, supplementary, or adjacent? Everybody good with the slide? All right, let's move on. All right, so now we have an example here. Now, this time I don't have numbers in the angles, so we're going to have to name our complementary angles with 3 letters. Can someone tell me two angles in this picture that are complementary and name it with 3 letters?
Angle BAC and angle RST.
Beautiful. Okay, angle BAC and angle RST. We could also go in reverse. We could have called it CAB and TSR. Everybody good on those? They both, when we add 32 and 58, it equals 90 degrees. So that is our pair of complementary angles. Let's find a pair of supplementary angles. Matthew.
Angle CAD and angle RST.
Okay, excellent. Angle CAD and RST. And put the little angle indicator in front of the letters. And again, you could have gone in reverse. Can someone name a pair of adjacent angles?
Angle CAB and angle CAD.
CAB and CAD. Wonderful. And those are adjacent. They're next to each other. They share a common vertex and a side. Any questions on the slide? Let's go to the next one. All right, here we have an application problem. It said, when viewed from the side, the frame of a ball return net forms a pair of supplementary angles with the ground. Find the measure of angles BCE and ECD. How are we going to go about finding those two angle measures? Isabella?
4x plus 8 plus x plus 2 equals 180.
Excellent. Okay, we know that supplementary angles, when we add the two angles, they equal 180 degrees. So we are going to write our algebraic equation, and we're going to put the 4x plus 8 plus x plus 2, and it's going to equal 180 degrees because they were said they were supplements. Okay, now I need to solve for x. What do I need to do to solve for x? What can I group together? How about the 4x and the x? And I get 5x. And then I'm going to group the 8 and the 2. I get 10. And now I'm going to subtract 10. I get 5x equals 170. I now have to divide. 170 divided by 5. 3. 2. X equals 34. Now, did it ask me to find x? No. What did it ask me to find? The measures of the two angles. So now I'll take my 34 and I'm going to replace them into each one of the expressions. So first I'll plug it into the 4x plus 8. So 4 times 34 plus 8. 4 times 34, 136, plus 8, gives me a grand total of 144 degrees. So BCE is 144 degrees. Now, at this point, how can I find ECD? Isabel?
By doing 180 minus 144.
I can do that, absolutely. I don't have to plug it back in. I can. So one way I can find it is if I know their supplements, subtract it from 180. Do the subtraction here and I get 36. Now I could have also taken the x plus 2, which is what ECD is, and then if I do 34 plus 2, I get 36. So my answers here are 36 degrees and 144 degrees. So it's just a way to double check that you've gotten two numbers or two angles that equal 180 degrees. Any questions on the sports example? Okay, let's see what's next. Some more vocabulary. So the next vocabulary words we're going to learn are a linear pair and vertical angles. A linear pair is when two adjacent angles whose non-common sides are opposite rays. Linear pairs always form supplementary angles. So here is a picture of an example of a linear pair. Notice it's sitting on a straight line. And together, they will always equal 180 degrees. Sort of look at the hint. The word linear pair has the word line in it. So they're two angles sitting on a line. Now the other type of angle we have here is called a vertical angle. And these are two angles whose sides form two pairs of opposite rays. Now, vertical angles, we're going to learn, are congruent angles. So it's basically X marks the spot. And if you sort of think of this being a V, and then we could put a line here and say like a V and an A, vertical angle. Whatever little trick will help you remember that they're vertical. Or just think when the two lines cross, it makes the letter V. Any little tricks that you can help remember. So the pairs of vertical angles in this picture are going to be the numbers 4 and 5 are vertical to each other, and 3 and 6. Those are the pairs of vertical angles. Any questions on linear pair or vertical? Let's go on. All right, we have our first algebra example. And here it's telling us that we have two angles and they form a linear pair. Now, for me in geometry, whenever I encounter a word problem and a picture isn't provided, I like to draw a picture. So I'm going to go ahead and draw a linear pair. So I got my line. And I'm going to draw in an angle, or a ray, I'm sorry, to create two angles. And it says the measure of one angle is 5 times the measure of the other. So if this is my first angle, I'll let X be the first. And then the other angle was 5 times the measure of the other. So then this one would be 5X. How much do linear pairs always equal together? How many degrees? 180. So if I set up my equation and set it up as X plus 5X equals 180, I can solve for X and then plug it in to find the value of my two angles. So when I group X plus 5X, I get 6X equals 180. Divide by 6, and X equals 30 degrees. So that's this one. And then the other angle will be 5X. So 5 times 30, which gives me 150. So again, you can double check yourself. Is 150 plus 30 180? Yes, it is. It does form a linear pair. Everybody good on this algebra example? All right, let's look at the next one. All right, now on this question, it's telling us the measure of an angle is twice the measure of its complement. Now, let's first think about complementary angles. So let's say I have a picture of a right angle here. And I'm going to divide it into two pieces. So if I told you that this piece is 30, and I've got the little box, so I know it's a right angle, I know it's 90, how do I go about finding the complement? What kind of math do I do here? How can I find out what X is if I know their complements? Subtract from what? 90. Okay, so this is how we're going to set up our problem to solve this one. I would have done 90 minus 30 to get its complement. So in this problem, I'm going to translate as I read. The measure of an angle, it's going to be X. the word is the equal sign, twice the measure of its complement. And I can find the complement by doing 90 minus x. And I'll put a 2 out front because it's twice. Find the measure of each angle. So here goes my problem. X equals 2 times 90 minus x. I'm going to distribute. I'm going to move the 2 over. Add it to both sides. I get 3x equals 180. Divide by 3. I find out that my angle is 60 because it was twice its complement, and we could tell that its complement was 90 minus 60, so the complement was 30. Everybody good on that one? Yes.
Why did you do 90 minus x?
Okay, so back here in this problem, so remember, if I told you angle x equaled, let's say, let me just not put a variable in here. All right, so let's say, let me write a new problem. All right, so let me draw a right angle, and I'm going to divide it up. And let me say that this angle is 20, okay? X equals 20. I want to find the value or the measure of its complement. And we know that complementary angles add up to be 90 degrees, correct? So to find the complement of 20, I need to do 90 minus 20. And that would give me 70. So here, I told you that 20 was x. So anytime to find any complement, you always take the value or the measure of that angle and subtract it from 90 to get its complement. Does that make sense? Okay, so that's why I did it. I didn't know what x was in this problem. I had to find it first. All right, everybody good on this? All right, let's try the next slide. Okay, now, you must always remember in geometry, we can never ever assume anything. Okay, right now, this angle up here, ABD, it looks like it's a right angle, doesn't it? But we cannot assume that because there's no square or a little box indicating it's a right angle. So given the picture as it is, I cannot assume that that is a right angle. All right, so what we can assume or conclude, what we can actually conclude based on the picture is that all of these points are coplanar. I could draw a parallelogram around it or a rectangle. All of those points are coplanar. We can also see that points A, B, and C are collinear. They're on the same line. We can also see that point B is in between A and C. Now, I didn't say it's in the middle. It's just somewhere in between there. I can also conclude that line AC, ray BD, and ray BE all intersect at point B, right here. So the line and the two rays all meet at point B. We can also see that angles DBE, this one right here, is adjacent or next to angle EBC. It's also next to ABD. Okay, we can also see that angle ABC is a straight angle. That's the only thing we can assume without markings. When we see a straight line, we know it's a straight angle. We can also see that point E lies in the interior of angle DBC. So what we can't conclude, I'll erase some of the highlights here. From the picture as it's given, even though it looks like AB and BC are the same length, we cannot conclude that. If they were to put in congruency marks, then we could say that they are congruent, like in the picture down here. Okay? We also cannot conclude that this angle is congruent to this one. They look like they're the same size, but because there are no congruency marks, we can't conclude it. And then the last thing, we cannot conclude that this is a right angle because it doesn't have the box. It must have congruency marks or a right angle indicator in order for you to know anything about the shape or the angle or the segments. Everybody understand what they were saying here? All right, let's look at the last slide. All right, here it wants us to use the pictures to find the measure of the indicated angle. So here it's asking us to find the measure of angle EFH. So let's highlight it. EFH is right here. What is the relationship between EFH and HFG? Can somebody describe those angles for me? Give me a name of them. Give me a vocab word. They're adjacent. Good. Somebody give me another name. They're supplementary. What else are they? What else do they form? A straight line, making them a linear pair. Okay? So we can see that both angles together, because they're supplements, will equal 180 degrees. So the equation that I'm going to use is I'm going to take 3x minus 6 plus 2x plus 16 and set it equal to 180 degrees because they're supplements. I will now group my x's and group my numbers and begin to solve my equation. I can group the x's and get 5x, and I can group the negative 6 and the 16 and get 10. It still equals 180. Subtract 10, and I get 5x equals 170. Divide by 5, and I get x equals 34 again. I now have to go back up and look to see which angle they wanted again. They wanted EFH. EFH was the 3x minus 6. I'll replace x with 34. Multiply 34 times 3. I get 112. No. I'm sorry, 102. And then I'm going to subtract 6. And I get 96. So the measure of EFH is 96 degrees. Let's look at part B here. Can someone give me a name for those two angle pairs?
Complementary, adjacent.
Excellent. Complementary and adjacent. So again, I'm going to set up an algebraic equation. I will take both pieces and set it equal to 90 degrees. So x plus 9 plus 2x equals 90. Group my like terms. 3x plus 9 equals 90. Subtract the 9. I end up with 3x. I'm going to move it down here. 3x equals 81. Divide by 3. and x equals 27. I now have to plug it in. They wanted the whole, no, they only wanted ABC. So ABC was the x plus 9. So 27 plus 9, and I get 36. Any questions? All right. So your homework tonight is the practice B. You have to turn it in. I have posted on Canvas, I added 2 more of the study guides for you guys to begin practicing for your chapter test, which is Tuesday. So the same study guides that I put up for the quiz, I just now have added lesson 1.4 and 1.5. So tomorrow in class, we'll go over the answers to tonight's homework, and then we'll begin reviewing for the test. All right, any questions?